Okay, so we're going to go over properties of limits. They've given us 7 formulas to help us solve limits. I'm going to try to explain these in simpler terms than what the symbols represent. This is saying the limit of some number k, k being a constant term. So there's no variable involved. So for instance, the limit of 5 as x approaches 2 is still going to be 5. It's going to be whatever our constant is. Okay? The next one, the limit of x as x approaches a. So limit, we'll say limit of, if our x is some variable, so we'll say, well, limit of x as x approaches 3 is essentially 3. That's all that's saying there, putting it into a formula. The next one, the limit of some function plus or minus another function is the same as finding the limit of the first function and then adding or subtracting it, depending on what they originally told us, to the limit of the other function. Okay? So if they ask for the limit of x as x approach 3, so x plus, let's say y, something like that, we would find the limits of each of those, x and our y, if we're adding them. And then we would just add the two at the end together. Okay? So we can break these apart. And we'll go through a couple examples like that. Number 4 talks about the limit of some function times a constant number is the same as just finding the limit of the function and then multiplying it by the constant after. Okay? So that would be like a limit of 3x as x approaches 2. Well, we find the limit of x, and at the end we're just going to multiply whatever the limit of x is by the number 3. The limit of some function multiplied by another function is the same as finding the limit of the first function, finding the limit of the second function, and multiplying the two of them together. 6, the limit of some function divided by another function is the same as finding the limit of the function on top, limit of the function on bottom, and just dividing the two, as long as the limit on the function of the bottom isn't 0, because then we have an undefined number. And finally, the limit of some function to the power of n is the same as finding just the limit of the function and then at the end putting that number to the power of n, as long as n is a rational number. Okay. So we put all those up. Let's go through a couple examples here. We'll go through example 2. So they want us to evaluate the limit of x as it approaches the number 2 for this function, 3x squared plus 4x minus 1. Okay? So when we go to do this limit here, I want you guys to recognize what they have. Okay? Essentially, they're trying to get us to find the limit of this. But this here has 3 terms. We have our first term, our second term, and our third term. Let's see if I can bring up 2 pages here. We're going to try to relate these. Our first term is actually similar to rule number 4, where c is our number 3 and x squared is our function. So what we're going to do is we're going to move that 3 out, and we're going to be looking for the limit of x as it approaches 2. But we're going to be looking for the limit of x approaches 2. And what we're going to do, I should move that, is we're going to move the 3 to the outside. Okay? And we're really just going to find the limit of x squared when x approaches 2. Okay? That's our first point. Our next point is, again, same idea, very similar to number 4. We're going to move the number 4 to the outside, and we're just going to evaluate the limit of x as x approaches 2. And finally, our third term is actually similar to the first rule we had there. Because it's a constant number, we're just going to go for the limit. So we're going to be subtracting the limit of 1 as x approaches 2. Okay? So we've related those to our rules over here. when we go back in, we'll be looking for the limit as x approaches 2. Okay? Now, technically, again, I should bring this up one more time. We can break our first term up one more time because it has an exponent. We're again looking at this rule here. We're going to break it up a second time. We're going to put 3 in front, and we're actually going to be just looking for the limit of x as x approaches the number 2. And then our number squared, we'll do that at the end. Okay? So that's related. So we've used rules 1, 4, and 7 for this question. Now, we can actually evaluate the limit of x as it approaches 2. As x approaches 2, it is pretty much almost the number 2. Okay? So what we're going to do here is we're going to be replacing, so we're going to be adding 4, and we're going to be replacing this limit of x as it approaches 2 as the number 2. Because as we get closer and closer to 2 without touching it, we're essentially, thinking of it almost like a rounding, we're pretty much at the number 2. Okay? Now this is a constant term, so the limit of 1 as x approaches 2 is still just the number 1. That's what our constant rule told us. It's just going to be that number. Inside our brackets here, limit of x as it approaches 2, already solved that. That's the number 2, and we're going to square it. This becomes 8 minus 1. 2 squared is 4 times 3 is 12, plus 8 minus 1 gives us 19. The limit of x as it approaches 2 is essentially 19. And I just want to draw your attention very quickly. Had we done that from the original, if we had essentially just plugged it in, which is going to be a lot of the cases for some of these, if we just plugged in the number 2 for our original question, okay, that was the original thing they gave us. This would have gave us 3 times 4 plus 8 minus 1. 12 plus 8 is 20. Would have been 19. Okay, pretty much the exact same idea as what we had before.